So we are going to look at the quadratic formula today. The quadratic formula is our fifth and final way to solve quadratics. So far we've talked about how to solve by graphing, how to solve by factoring, how to solve by square rooting, and how to solve by completing the square. The quadratic formula is actually, it comes from completing the square, but it's, I think, a little bit easier to handle when your a doesn't equal 1, because you don't have to do quite as much with fractions. But I'm going to go through a couple of examples of the quadratic formula. Then we're going to talk about some discriminant stuff and what that means for the number and type of solutions now that we've introduced this idea of an imaginary number. Before we get into that, we need to make sure that you know the quadratic formula. So here's a video. A quadratic formula is best memorized by using the tune of Pop Goes the Weasel. Here it is.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
One more time for good measure.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yes, you will have to have that memorized. So watch that as many times as you need to. But let's get into actually using it. So, and I might get a little quieter, but I'll try and speak loud. The first thing that we're going to have to do when we use the quadratic formula is we need to start by identifying what a, b, and c are. We did this when we talked about standard form in chapter 2, and our a is just the number in front of our x squared. Since there's no number there, a equals 1. B is the number in front of our x term, so negative 6, and c equals positive 8. Then we just have to plug it into that formula. So we have x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 8, all over 2 times 1. That's the only real new thing here. The rest of it is just simplifying. So negative 6 becomes positive 6 plus or minus the square root. Negative 36 squared, negative 6 squared is 36. Minus 4 times 1 is 4, times 8 is 32, all over 2. That equals 6 plus or minus the square root of 4 over 2, which equals 6 plus or minus 2 over 2. Keep going. We can split that up into 6 plus 2 over 2 and 6 minus 2 over 2. So that equals 8 over 2, which equals 4, and 4 over 2, which equals 2. So ultimately, x equals 4 and positive 2. Here's the thing with this problem. Yes, quadratic formula will work. Quadratic formula works every single time. But it takes a while to do the simplification. If I looked at this problem, though, I would rather factor it because I would see right away that x squared minus 6x plus 8 factors into x minus 4 and x minus 2. Set each of those equal to 0. And solve. X equals 4, x equals 2. That's going to go a lot faster if you solve this one by factoring. But if you can't figure out the factor, the quadratic formula is a good place to fall back on. Let's get another one. So, we have this x squared minus 6x equals negative 9. The only difference in this one is that we cannot use the quadratic formula unless it first equals 0. So we need to start by moving that negative 9. So we get x squared minus 6x plus 9 equals 0. And then we just go through that same process. A equals 1, b equals negative 6, c equals 9. So x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 9 all over 2 times 1. Simplify it. We get 6 plus or minus 36 minus 36 over 2, which is 6 plus or minus the square root of 0 over 2. The square root of 0 is just 0. And it doesn't matter if you're adding 0 or subtracting 0, it's the same thing. So we can really just simplify this to 6 over 2, because 6 plus 0 is 6. 6 minus 0 is still 6, so 6 over 2, which just equals 3. So this one only has one solution of x equals 3. This is another one that you could have solved by factoring, because x minus 6x plus 9 is just x plus 3 squared equals 0. And then you could have used the square root method from there. But you could solve it by the quadratic formula as well. Let's check out one more example. Again, it has to equal 0. So let's move that 6x. And we get x squared minus 6x plus 10 equals 0. A equals 1, B equals negative 6, C equals 10. So x equals negative 6 plus or minus the square root of negative 6 squared minus 4ac all over 2 times a. Start to simplify it, and we get 6 plus or minus the square root of 36 minus 40 all over 2. So 6 plus or minus the square root of negative 4 all over 2, which is 6 plus equals 6 plus or minus 2i over 2. And now I need to finish simplifying this. I can see that 2 divides both 6 and 2i. So I can just simplify those by doing 6 divided by 2 plus or minus 2i divided by 2, which is just going to equal 3 plus or minus I. So x equals 3 plus or minus I. Okay, so that's how we would go about solving these different equations. Now, let's check out this stuff about discriminants. So on the back side of your paper, you have those same 3 equations from the front side. We've already figured out their solutions. We know the first one, that x squared minus 6x plus 8 equals 0, had the solutions of x equals 4 and 2. And if we look at that graph, that matches. So we know we did it right. The second one has the solution of x equals 3, and the last one has the solution of x equals 3 plus or minus I. Again, those graphs match that solution. On this first one, let's go all the way through this. So, the number and type of solutions. There are 2 solutions, because 4 and 2, and they are both real. So we say that there are 2 real solutions. On the second one, we have 1, and it's real, so we say there's 1 real solution. On the last one, we do have 2 solutions, because we have 3 plus I, as well as 3 minus I. Those are 2 different solutions, but they both have an I, which means that they're both imaginary. So we're going to say that there are 2 imaginary solutions. All right. So then, if we look at the number of x-intercepts, if we look at the graph, that tells us stuff about our solutions as well. On our graph, we have 2 x-intercepts. There are also 2 solutions. Remember that your solution and your x-intercept are the same thing. So if there are 2 real solutions, there will also be 2 x-intercepts. If there's 1 real solution, there's going to be 1 x-intercept. So there's 1 spot where the graph touches the x-axis. If there are imaginary solutions, see how that doesn't touch the axis at all? So there are 0 x-intercepts. Oops, mix those up. x-intercepts, though, of this first one. We're at 4, 0, and 2, 0. On the second one, it was at 3, 0, and on the last one, there were none, so it's not applicable. There were 2, 1, and 0. Then we have this thing called the discriminant. So the discriminant is just the stuff that goes under the square root. It's that b squared minus 4ac. So in that first example, if we look back to what we wrote under our square root symbol, this guy here, and if we copy that down in this box, so the negative 6 squared minus 4 times 1 times 8, that's our discriminant. We simplified that previously, and we found that it equaled 4, and 4 is greater than 0. So anytime you have the discriminant greater than 0, you know that you have 2 real solutions and 2 x-intercepts. On the next one, our discriminant was negative 6 squared minus 4 times 1 times 9. And when we simplified that, it was 0, which of course just equals 0. Anytime you have a discriminant that equals 0, you have 1 real solution and 1 x-intercept. Lastly, we have the discriminant of negative 6 squared minus 4 times 1 times 10, which gave us negative 4, which is less than 0. Anytime our discriminant is less than 0, we're going to have 2 imaginary solutions and no x-intercepts. This is the most important part about the discriminant, is knowing that if it is greater than 0, you have 2 real solutions and 2 x-intercepts. If it is equal to 0, you have 1 real solution and 1 x-intercept, and if it is less than 0, you have 2 imaginary solutions and 0 x-intercepts. Let's emphasize that again as we look at these last 3 examples, where we are just going to find the discriminant to determine the number of solutions and to talk about the x-intercepts on the graph. So, again, the discriminant is just b squared minus 4ac. So if we do our a equals, our b equals, and our c equals, we'd end up with 1 squared minus 4 times 1 times negative 1, or 1 plus 5, which just equals 6. 6 is greater than 0. I multiplied funny. Hang on. My bad. That should be a 4, and that should be a 5. I even have this written out. This is disgraceful. 4, 5, 5. There we go. That makes more sense. 5. Yeah, 5 is greater than 0, so we have 2 real solutions and 2 x-intercepts. On this one, again, it has to equal 0, so we've got to move that 6. So 7x squared minus 3x minus 6 equals 0. A equals 7. B equals negative 3. C equals negative 6. Got b squared minus 4ac. So we'd end up with 9 minus 168, which would give us negative 149. Negative 159, I said 49, it's 59, is less than 0. That means that there are 2 imaginary solutions and that there are 0 x-intercepts. Lastly, again, it has to equal 0, so let's move that 6 and move that 10x. So we have negative 5x squared plus 10x minus 5 equals 0. A equals negative 5, B equals 10, C equals negative 5. And then we have b squared minus 4ac. So 100 minus, so negative times a negative is a positive, times another negative is a negative. 4 times 5 is 20, times another 5 is 100. So we get 100, which just equals 100, which means that we get 0, which equals 0, which means that there's one real solution, and that there would be one x-intercept. That's it for the notes. If you need to rewatch any point, please feel free to rewatch any part of these notes until they make sense to you. I will answer questions when I see you again, either on Thursday or Monday. But now you should work on your 3.4 assignment. You should also be working on your review guide. So feel free to email me if you have any questions, but that's all there really is to the quadratic formula.